Hi everyone. Today we're going to continue learning about the geosphere and we're going to take a look at some questions that I would normally face if I had you in the classroom. So, if you need to get a hold of me, my email address is on the screen. It's rcrawford@jcpsmail.org. Please remember, if you put a note in on an assignment in Google Classroom, it may take me days to get it. Please use my email. Here we go. So, the first idea, and this may seem rather obvious, but we need to at least say it out loud, is that as we go deeper into the geosphere, meaning as we go from the surface and further towards the core, we're going to find that pressure increases. Okay, and by pressure, I mean a squeezing force. So, it is nearly 4,000 miles from the surface to the center of the core. So let's think about why the pressure is increasing. Okay, so most of you understand that a rock as a material is very heavy. So if we have a 2 foot by 2 foot by 2 foot rock, that's 8 cubic feet. We're going to be looking at a rock that weighs almost the same as a small car. If we were to take and double that, if we have one that's 4 by 4 by 4, we have a rock that's going to be much heavier than even some of the biggest trucks that we have. Okay, so first off, rock is a heavy material. Okay, I love this picture. This is a piece of rock that was ejected from a volcano during a volcanic eruption, and it landed on this car. And it gives us a really good sense of, exactly how heavy a rock might be. So we're back here. Let's think again. So pressure increases. Remember, pressure is that squeezing force, and rock is very heavy. So if we were to move just a little bit of the way into the crust, let's suppose we move down just maybe 50 feet underground, we're going to find that we have 50 feet of rock over top of us, right? So that's going to be an incredible amount of weight pushing down and squeezing us. And obviously, the deeper we go, the more force we have pushing down on us, the more pressure. When we get down near the core, scientists have estimated that there is almost 45 million pounds per square inch of pressure that is squeezing down on us. And the reason there's so much pressure is just simply the weight of all the rock that is resting over the top, right? So gravity is a force that pulls down. And so the weight of the rock is what creates this incredible pressure. This incredible pressure creates some very interesting um, sort of dichotomies. All right, so pressure increases with depth in the geosphere. Now, this is a thing that most of you already know, I think. Temperature also increases with depth. Most of you know that it's hot inside of Earth, and even though you may not be able to put a number with that, you do understand, I think, that the deeper you go, also the hotter it is. Okay, so temperature increases with depth. So we know that the top of the crust, right? That's the part that we walk on, is relatively cool. It can be, anywhere from 0 to 70 degrees Fahrenheit. But if we go just down to the bottom of the crust, and the crust here is shown as this brown layer, remember it's the thin outer layer, you're going to have the bottom of the crust reach temperatures of almost 2,000 degrees. Now realize at this point you're probably 50 miles underground in some places where it's very thick, but 2,000 degrees. In the mantle, the range from the mantle, when we go to the bottom of the mantle, so the top is of course going to be 2,000. When we go to the bottom of the mantle, the temperature there is going to be it's going to be over 6,000 degrees. And as we reach the core, of course, this is where our temperature is going to be the greatest. We estimate that at the center of the core, we're going to have a temperature that's going to be almost 11,000 degrees. Guys, that's almost the same temperature as the surface of the sun. So temperature increases with depth. Okay. I think most of you know that it's hotter inside of Earth because you guys understand that volcanoes or some of that melted rock is coming from inside the Earth. And if rock is melted and rock doesn't really melt to, anywhere around 1,500 to 2,000 degrees, then it must be pretty warm down there. So both pressure and temperature increase with depth. So some of you may be asking, why? Why is it hot inside of the Earth? And I won't get into great detail, but the primary reason, the main reason, is going to be the decay of radioactive elements. When some elements that are radioactive decay, they produce heat. So this is a sample of, I believe this is uranium. So this is a sample of either uranium or plutonium, and you can see that it is producing so much heat that it is hot. Now, it is not being heated by an external heat source. It is producing this heat on its own. Okay, so we take advantage of this and things of these radioactive elements and things like nuclear reactors, right? And so we use that heat that it makes to make steam, which of course turns a turbine and generates electricity. Down here, we can see the periodic table. If you're curious about which elements are radioactive, anything that's in red down here is going to be a radioactive element. The big three scientists believe are thorium, uranium, and potassium. Okay, so the main source of Earth's internal heat is going to be the decay of radioactive elements because they just naturally produce heat as they just basically sit there. So we have this heat inside of Earth, and of course we know that if it's hot in one place and we have a cooler area, heat flows. Heat always flows from warmer to cooler. So if it's very warm here in the core, 11,000 degrees, and we know that the surface is going to be much cooler, then we know that we're going to have heat flowing this way, or it's going to flow from the core toward the surface. So when we talked about the ways that heat moves, one of the ways we talked about was convection. And that's exactly what is happening as heat moves from the core through the mantle and makes its way up to the crust. Now, one thing that's very strange is a lot of students tend to imagine that the mantle must be made of magma, of melted rock. That is simply not true. Magma is made of, well, it's really made of semi-solid rock, but if you were to look at the rock, you would definitely think that it was solid rock. So it's made of very, very hot rock that is able to bend and become sort of not rock whenever it is as hot as it is. Now, this rock is only going to flow a couple of inches a year, right? It's not going to flow like a liquid would because it is not a liquid. This is not magma. It's going to be a semi-solid. Okay, so heat is going to flow via convection currents, right? These up and down currents, and it's going to flow very, very slowly through the semi-solid rock. And remember, when we have two of these side-by-side currents that are rotating, convection currents that are rotating in opposite directions, we call that a convection sail. Okay, all right. So, another question that I often get in class is, Mr. Griffin, how do we know? How do we know what it's like inside of the Earth? This is a really solid question, and it's taken us quite some time to really work out how we know. Obviously, we have only been able to drill a tiny ways into the crust. We've been able to drill about 5 miles down off into the crust. Okay, and that's not a lot, particularly because from the surface all the way down to the core is almost 4,000 miles. So we have just barely been able to drill down any at all. So one way that we know is earthquakes. So earthquakes is a shaking of the ground. It releases vibrations or releases waves when an earthquake happens. And so when an earthquake happens, it's going to release all this energy in the form of waves. And those waves they're going to radiate outward in every direction. And when it does that, scientists can study how these waves behave and how they interact, and they can really get a good picture of what's happening inside of Earth. And now, some of you may be like, how can we use waves to see things? But if you take just a moment and really consider, this is called an ultrasound, right? So this is where we can use some waves that are like really low frequency sound waves, and we can get a picture of a baby inside of a mom's belly. So getting this picture in an ultrasound is really no different in principle from how scientists are using these powerful, powerful earthquakes to see what's going on inside of Earth. So one way that we know is by earthquakes. Another way that we know is volcanoes. Volcanoes are a place where we have like molten rock most of the time, and ash and these other materials that are going to be ejected from the Earth's crust. And so, what scientists will do is they will take samples of this lava, and then they will study, what type of material is the lava made from. They'll study the temperature of the lava. So, really, scientists use volcanoes to really learn quite a bit about what's going on inside of the Earth. All right. So, guys, that's going to do it for our video today. We will continue to study the geosphere, and look forward to seeing you soon. Bye.